This video demonstrates the process of using a spreadsheet, a worksheet developed by MDOT, to design mast arms for given sites. So this drawing shows the standard details of a traffic signal mast arm pole and mast arm detail for category 1 design. So there are different sheets for category 2 and category 3 designs. So this is with all possible attachments and other members included in this detail. But this detail may not be suitable for a given site, so we will have constraints to implement it. In that case, we need to customize and come up with a specific detail that will be suitable for that site, but still we have to make sure it is within the limits of the standard design details. For example, this mast arm has multiple attachments or equipment, and also a lumina arm, and also the truss. And there can be additional attachments. So there's a list of equipment provided that can be attached to the mast arm as well as to the pole. But for a given site, for example, the site shown in this PDF, there's a mast arm required for this corner of the intersection, this location. So it required a long mast arm along this direction and a short mast arm in this direction, because this has to cover 2 lanes and this one has to cover a straight lane as well as turning lane. And also it has to cover this direction. There's a traffic lane, straight lane, as well as a turning lane. So all this needs to be covered with additional attachments on the structure. So this seems like different from the standard detail. So in that case, we need to go and check if this design is within the standard design limits. For that, MDOT website provides a worksheet. So it's called the mast arm design worksheet. This has multiple sheets. So it has a change log showing all the changes or the updates. So this is the latest version, version 1.4.1, and the updated date is April 14, 2025. And also there's a sheet with instructions describing how to use this specific worksheet, and there are options to use a single mast arm or twin mast arm. And then the sheets have certain cells highlighted in different colors. Yellow highlighted cell requires user input. Then there will be bluish color cells. It will include the calculated values using input data as well as some reference values embedded in the spreadsheet. There will be certain cells populated with reference values based on the input values. These reference values are already embedded in the spreadsheet with some hidden sheets in this worksheet, and they will be selected based on input values and displayed. At the end of the design, you will get the final design details, and we call them the key values. For example, if you go to mast arm 1 design sheet, so all these yellow cells require user input. This green one will be populated with reference values embedded in the worksheet based on the input data. So if it is a single mast arm, we need to complete mast arm 1 design and the mast arm pole design. Then you can observe the results and whether all the checks are passed or failed. Whether there are certain conditions that require adjustment of the design. If it is a twin mast arm, you need to complete mast arm 1 design sheet, mast arm 2 design sheets, and the pole design. One point you need to remember, if it is a single mast arm, you have to make sure mast arm 2 Yellow cells are empty. Okay. And then we'll start with Masta 1 design sheet. So I'm going to work with the fictitious site. So assume it's a site M43 at West Main, Ostemo Township in Kalamazoo County. And then the signal spot means the location of the signal. So it is at the northeast corner of the intersection. And then as the designer, you need to include initials and the date. And for this site, we have decided to go with the category 1 mast arm, and we want to have 50 feet long mast arm. So once you include this, if these green cells are populated with some numbers. So these are the section details for the inboard mast arm and the outboard mast arm. So inboard mast arm is 20 feet long, outboard mast arm is 31 feet 11 inches long. So combined, it's little more than 50 feet, but it will be 50 feet because this is going to have a splice connection. So we'll adjust this length and the final length will be 50 feet. The arm is pointed towards west. So we include west over here. So in this structure, we are going to have, so there are some restrictions when we have two twin mast arm. So there's a signal that we are not supposed to include. So because of that, I'm going to leave this row empty. So I'm going to start with 2. So the first one is located at 34 feet from the face of the pole. And the second signal is going to be at 42 feet. And the last one is at 50 feet. Then we also have a road sign at 4.5 feet. So now I have to select the equipment. So there's a pull down menu and there's a list of equipment embedded in this spreadsheet. So the first one is going to be 3C. Yeah, with CES with BP. So second one is similar. And then the third one is a doghouse signal, is 5C. So it's very hard to see everything. So you have to select one and see if it is the one that you're looking for. So I like to see one with the backing plate. Yes, so this is with the backing plate. And then this is the signal, street name, sign. So it's 1W. $24.96 street sign. So if there are some equipment that are not listed in this pull down menu, you can define them here. You can define the height and width, or if there are additional, the weight information of these. So we need to include the weight and also other dimensions. But right now, for this structure, we have all the predefined attachments or equipment that we can select. So once you define these, we have a graphical representation of the location of these attachments or equipment. So we can visually verify their locations or the accuracy of input data. So that's all we need for Masta 1 design sheet. Since this is a twin mast arm, I'm going to use mast arm 2 design sheet also to provide additional data. So over here, we don't need to fill these because they are taken already from the previous one. So now only thing we need to select is mast arm 2 length, and I'm going to select another 50 feet one for the site, and this one is going to face south or point towards south direction. Again, this one has 20 feet segment and a 31 and 11 inches, 31 feet and 11 inches. So the total will be 50 because of the splice connection. And this also we have similar signals. First one is 34 from the face of the column, 42 feet and 50 feet, 4.5. So these numbers going to change depending on the site conditions. So in this particular case, I'm using the same numbers. So first one, so I need one W3C with WP. Second signal also I need a similar one. And third one is a doghouse signal. And then fourth one is a street sign. It's 124.96 street sign. So again, we get the visual representation of the selected equipment. If we have certain equipment that's not in this pull down, listed in the pull down menu, then we can define the parameters in these yellow cells. So that's all we need to do in sheet 2. Then we can go to the pole. So again, you can see all these green ones are populated. So we need to include details regarding the pole and its attachments. So in this particular design, we need a lumina. And then lumina arm span, we need to select only for category 3 structures. So we are designing category 1 structure, so we leave it blank. Then we need to have a truss arm, and then the truss arm span length. So there are standard drawings that details that we can go and look at different truss arm configurations. So there's one for 18, and also over here the pull down menu lists the span length. So we need 18 feet long one for this site. So the rest of the information either taken from the previous sheets or embedded details like the pole size and the pole height. Then on the pole, I have two pole mounted pedestrian signals. Pole mounted pedestrian signals, I have two of them. And they are located at 9.67 feet from the base plate. And also it needs a 1W3C signal. PC with the backing plate. And also it needs a GPS module. GPS module and an antenna. So the distance is 10.33. GPS module is at 12.67, and the antenna is up on the pole, so that's 30.33. Since we selected the truss arm, so we need to have it pictured. So the distance to pole base plate, 32 feet. It will have a microwave vehicle detector. The final step is to go and review the results. So as you can see here, green ones already populated from pre-existing values, input values, or the pre-existing values embedded in the spreadsheet. Here's the final results. So it's a category 1 50 feet mast arm. It's a twin mast arm and a 289 feet pole. So here's the mast arm member, and then this is the mast arm 2 member, category 1 50 feet, category 1 50 feet, and then all the design checks are passed. This ratio should be 1 or less than 1 to pass the checks because it's a demand over capacity. So all the checks passed, and the pole is category 1, 29 feet. Here's the cross section of the pole and the length of the pole. Also, demand capacity ratios are less than 1, so all the checks passed. So now if we want to see how things can fail, so there can be different numbers you can play with. So if you go put like 55, then there's a warning telling that it can be a value because mast arm length is 50 feet. So it has to be a value 50 or less than that. Then visual diagram will help you to verify it. So if you add more size, and there can be a situation where the checks will fail. But this design, everything is satisfied. So you can have a twin mast arm at this particular site located at the northeast corner and pointing one on the west direction, the other one on the south direction. So this concludes this video.